Welcome to the chapter overview of chapter number 2, Acids, Bases, and Salts, where we decode the chemical forces of acids, bases, and salts. These fundamental compounds are defined by their behavior and the ions they release in solution. Acids and bases exhibit distinct observable properties. Acids taste sour and turn blue litmus red. Bases taste bitter and soapy, turning red litmus blue. Chemical indicators, like phenolphthalein and methyl orange, show unique color changes, further distinguishing them. The core difference lies in the ions they produce in water. Acids generate hydrogen or hydronium ions. Bases generate hydroxide ions. Soluble bases are known as alkalis. Acids require water to dissociate and exhibit their properties. For example, dry HCl gas is neutral. Only when mixed with water do the ions separate, and the solution becomes acidic, as shown by the litmus test. Acids react with active metals to form salt and hydrogen gas, a reaction known as the displacement of hydrogen. For instance, zinc reacting with sulfuric acid yields zinc sulfate and hydrogen gas, which creates a, quote, pop sound when ignited. Acids also break down metal carbonates to produce salt, water, and carbon dioxide. The CO2 gas released can be identified by passing it through lime water, which forms a white precipitate of calcium carbonate. Neutralization is the reaction between an acid and a base, canceling their core identities to form salt and water. At the ionic level, H+ from the acid combines with OH- from the base to form H2O. The pH scale maps the concentration of hydronium H3O+ ions. pH below 7 indicates acidity, where H+ dominates. pH above 7 indicates basicity, where OH dominates. pH 7 is neutral. The pH balance is vital for life. Human blood must stay within a narrow pH window. High acidity, like stomach acid, is essential for digestion, but needs to be neutralized if overproduced. Acid rain is an example of an external pH imbalance. In the wild, nature uses neutralization as a defense. Bee stings and nettle hairs inject methanoic acid. The antidote is a mild base, like baking soda or a dock leaf, which neutralizes the acid and relieves pain. Salts are categorized into families based on the acid and base they are derived from. Combining a strong acid and a strong base yields a neutral salt, pH 7. Combinations with weak components result in either basic or acidic salts. The chlor-alkali process is an industrial method using the electrolysis of brine, $text sodium chloride, plus text H, _2 text $, to produce 3 valuable products: chlorine gas, hydrogen gas, and sodium hydroxide. Common salt, sodium chloride, is a precursor to several key chemicals. Adding chlorine yields bleaching powder. Reacting with carbon dioxide and ammonia produces baking soda, which is used to make washing soda. Many salt crystals contain water of crystallization, a fixed number of water molecules locked into their structure. Heating removes this water, changing the crystal's color and form. Adding water reverses the process. From biological defenses to vast industrial processes, the interplay of acids and bases governs our world. Understanding the exchange of H+ and OH- ions allows us to maintain balance and synthesize new materials. Thank you for learning with us. Meet you in the next chapter overview.